Last up is Erwin Hofman. Erwin specializes in core web vitals. If you didn't know this by now, that is a very important topic for performance. And Erwin is going to take a deep dive into that with his talk, Shopware 6 as your ideal core web vitals boilerplate, ? Erwin, take it away.
Thank you, Sander. Yeah, let me first elaborate on the accelerated mobile pages question. Obviously, accelerated mobile pages has a lot of bonus points towards performance. As a matter of fact, all those bonus points, all those best practices can be implemented in, well, maybe not any shop, but could even be implemented in Shopware. So if you're really considering doing AMP, accelerated mobile pages, well, Sander already posted the link in the chat. Don't do it, because you're basically building yet another front end, and you end up maintaining maybe two versions, because often AMP is just like a lightweight version of your regular page, but you're limited to a certain amount of CSS, but also a certain amount of JavaScript. So you always have a very lean page, which is maybe good for user experience and perceived performance. But I would then advise to put those efforts into your own shop, optimizing your very own shop. And yeah, it could be a bridge to my talk in such a way that Shopware 6 already is quite a good boilerplate. For example, if you compare it with Magento 2, Magento 2 has quite a bit of JavaScript going on, which is really impacting performance, like Thomas was already explaining as well. And it isn't just JavaScript, which is the bottleneck, but it's also how you use JavaScript. For example, Magento is already loading often they're already loading JavaScript first things first. So it's really render blocking, but also parse blocking. So it keeps the browser from doing what it should be doing. What Shopware is doing is it's basically deferring all JavaScript because it's moved to the footer. So if you move JavaScript to the footer, it's the same, it's the equivalent of deferring JavaScript. There's a little nuance, but not important for today. So this basically means Shopware is already enabling the browser to do its work as fast as possible without really pausing it. And sure, CSS is still render blocking, and you could implement strategies and best practices like AMP is doing as well, etc. Accelerated mobile pages is using critical CSS. However, critical CSS implementing critical CSS can be quite tricky and also come with layout shift challenges, for example. So I would say put critical CSS at the end of your to-do list. All right, I'm going to start sharing my screen. Because, well, any green score in LinkedIn or whatever platform might always be doing good, like this one over here as well, my very own post, 98% score. However, this score doesn't matter at all. And the reason is exactly, well, what Thomas was already explaining as well. It doesn't matter because it's lab data, it's syntactic testing. A lab data test in, for example, Lighthouse or PageSpeed Insights might be done on certain circumstances. And it doesn't tell the whole story about real user experience, the so-called field data. And to answer another question, well, not really a question, but all this data is only coming from the so-called Chrome user experience report. It's not coming from Google Analytics, it's only coming from one database, and all Chrome devices are basically, without knowing, basically submitting all their experiences and metrics to the so-called Chrome user experience report. So one takeaway might already be this overall score, 98%, even on mobile. Yeah, it's a good score. It will always work on LinkedIn to get some engagement, but it doesn't matter. And the subject I was talking about in this very specific post is when you would enlarge your image, you get a better score, which might sound a bit weird, but this is exactly how Core Web Vitals is working. The so-called largest control paint might often be the hero image or product, if the product image, for example. And it looks at when the largest image is done loading or the largest text node is done loading, like a heading, for example. And we enlarged the image to, well, span the whole width and height, the full viewport dimensions, you could say. And this is how Core Web Vitals is working. When an image is full width and full height, then Core Web Vitals, or you could say Google, is considering it as a decorative image instead of a meaningful image. So it won't see such image as a largest control paint. So that's why we got a high score over here. So if you've got any homepage, for example, with already a very big image, then try to make it a full viewport image instead, and you get a better LCP for free. All right, that being said, I won't dive into each Core Web Vital metric today, but I will dive in a use case in a shop I used and audited, also in preparation for this talk, but also to enable them to speed up. And this basically is, you could say, complementary to earlier talks. For example, to start with, time to first byte. And we did some real user monitoring over here as well, because, well, Core Web Vitals is, once again, about your real audience, meaning if your audience is within Europe, for example, or the Netherlands, I guess internet connectivity in German isn't as good as in the Netherlands, but we're a smaller country, so it might be a bit easier to get everyone a good internet speed. But the time to first byte, I audited this website using real user monitoring because the Core Web Vitals of Google themselves didn't have sufficient data for all different pages. And also the field data of Core Web Vitals isn't from day to day. So you can't see any changes, for example, in improvements in your scores. You have to wait 28 days before seeing any results. And it's a bit, well, especially when you're doing multiple releases in a week, or maybe one release in a week, you don't know if it improved or decreased performance, for example, if it improved user experience or not. Time to first byte is one of the first metrics I like to look at when auditing a web shop. And what I see over here, what I saw happening is at the 75th percentile, the overall experience was, more than 800 milliseconds. And the biggest bottleneck was when users tend to visit the page using, advertisement links. So when they would click on a Facebook ad, for example, or Google ads, or even any campaign parameters in the URL. So what you see over here, the 456 milliseconds is caused by users visiting the web shop without any query strings, without any parameters in the URL. And it resulted in a good time to first byte at the 75th percentile, once again, with a total 65% having a good time to first byte being below 300 milliseconds. And users having a query string in the URL, so visiting a page with a query string, ended up having a time to first byte of 3 seconds at the 75th percentile. So we can see over here that about 68% had an experience of more than 1 second. So this already is a quick fix in such a way that you then just have to configure your CDN, for example, in this case, Bunny CDN, but you can do it for any CDN, obviously, to configure it in such a way to ignore those query strings when they, basically aren't changing any contents. So, and the average Google ad, for example, or the average Facebook ad or campaign won't change any contents on the page. So you can just serve an already cached page. All right, and this is also a takeaway when it comes to Core Web Vitals, because Core Web Vitals is tracking all page views. It's not only tracking the first page view, so it won't only track uncached pages, but also successive page views, for example, or when a user is coming back to the shop the following day. And you can clearly see a change, a difference within visitors visiting a shop for the first time, without any resources cached, like CSS, JavaScript images, but also, for example, successive page views. So the second page hit, the third page hit, etc., where both resources, but also the DNS lookup will be cached in a browser, for example. And well, yeah, the difference is quite obvious. And the returning visitors are users who are likely to have some resources cached, but then will return maybe, well, the following day, and a new DNS lookup has to be done. So once again, it isn't about lab data, because lab data will only track fresh page load with all resources, well, all uncached resources. But the average experience obviously also is about, well, successive page views. You also want to have your visitors to have an optimal experience on, well, when they go to the cart, or when they go from a listing page to a product page. This also isn't something that Core Web Vitals will tell you. You aren't able to see what really impacted your maybe negative Core Web Vitals score. So this website, this is the web shop, I should say, this is the LCP. This website is likely to overall to pass Core Web Vitals, but if you would only take into account the unique page views, for example, it wouldn't be passing Core Web Vitals, and it might make you blind for, well, yeah, the first time page view experiences. So once again, Core Web Vitals is quite handy. It's actually quite transparent as well. It's already giving us some goals, some clear goals, not only for your SEO ranking, for example, but also for your bounce rate, because yeah, those metrics weren't taken out of the blue. Google came up with a certain set of metrics, currently 3 metrics, because they found out that when you would meet the thresholds of those 3 metrics, the chance of a bounce, the chance of page abandonment would decrease by 24%. So you would benefit SEO-wise, but also conversion and bounce-wise. This is the page load metric. And yeah, this is the page load metric. And once again, like Thomas was explaining as well, the amount of resources does matter towards certain metrics. In this case, we can clearly see that, well, this is not the internet speed, this is the device memory. So this basically means how much your device can handle, can process. And we can see a clear difference in, for example, a 2 MB the device memory, or more than 2 MB, yeah, 2 gigabytes memory, or 8 gigabytes memory, that there is quite a difference within the experience the user will have, depending on their yeah, circumstances. And I also have an option to, for example, set it to the bandwidth, the internet speed. And what I found out is from 4 MB internet speed doesn't have a correlation towards user experience. So obviously the average website will be about, well, around maybe 2 MBs or maybe 4 MBs, somewhere in between. And as of 4 MB, the internet speed doesn't have a real correlation towards, well, the UX metrics, the user experience metrics. And it's basically proving that there are different metrics in play. You have to take into account different factors. It's not only about internet speed, but also about user and device circumstances. This isn't QuickParts anymore. The QuickParts DK webshop, which I audited. I will come back to that later. But we can also see a clear difference within different devices. Desktop will often perform better than the mobile device. Once again, this is the 75th percentile, and tablet devices tend to perform even worse than both mobile and desktop. And this is the internet speed I wanted to point out, is it? Yeah, this is the bandwidth. And I hope I'm able to tell the same story over here, that we can see at 1 Mbps, there is an experience around 3 seconds for the largest control pane. So that will be the main image, product image or hero image. And as of 4 as of 4 Mbps, we don't see a clear correlation. Like 5 Mbps has a better experience than a worse experience at 6 Mbps, and 5 Mbps even has a better experience than 7 Mbps or 8. And we do see that anyone above faster than 10 Mbps internet speed has a better internet connection, but it can also be like 50 Mbps. So they will always have a better experience than someone with 8 Mbps. But we also see that the correlation here is no longer there. And this is once again, well, this is a Dutch web shop, and we can even see data per page type. But also this depends on is someone using a mobile device? Is this the first page hit? What kind of memory does the device have, etc. So they're all different kinds of circumstances we have to be aware of. It's not only server side, but also perform front-end side, client side, which matters today. Going back to the web shop which I audited, this is the quickparts.dk. And next to doing some real user monitoring, I also dived into a web page test. And if you haven't read my article yet, then I'll just be diving into some quick wins. And one of them is Google Fonts. Google Fonts is all okay to use in such a way that often it won't be the biggest win towards Core Web Vitals, for example, also because their servers tend to be quite fast. However, it might impact the first visit because, as we can see over here, we see some colored bars, which is the DNS lookup TCP handshake, for example. And obviously, it has to be done the first time. So it might slow down the first page experience a bit more than, for example, successive page views. Moreover, we see in this specific test, tested from Amsterdam on a Motorola device, we see that the first control paint happens at 2.8 seconds. It's all blank at 2.7 seconds, and at 2.8 seconds, we almost see the whole screen at once, which means there is a very big random blocking issue going on over here. And this was quite an interesting find, although not rocket science, but this is the style sheet. And this used to be a very good, well, I'm not sure if it's a very good practice, but this used to be a good practice, importing another style sheet in your very own style sheet. And I also see this happening, for example, on Laravel shops or Laravel sites. And when you use add import in your CSS style sheet, the add import fetch will only be done, executed once the whole style sheet was downloaded, obviously, because the browser won't know what's in the style sheet until it's fully downloaded. So the browser will download the whole style sheet, and only when the whole style sheet was done downloading, it's able to, well, tell or see which other files should be imported. And this is basically resulting in a chained reaction, you could say. It's basically resulting in a chained delay, because that's what we can see over here quite clearly. I've got a red vertical bar. Let's enlarge my screen a little bit. And we can see that at request number 2, at my red bar, the download of my primary CSS was done downloading. And that's exactly the moment where another style sheet started downloading. So we can basically draw the conclusion that we introduced a bottleneck of more than 700 milliseconds, which is easy to fix by not putting such Google font in our own style sheet using add import, but by using a regular link element in a primary HTML payload, for example. That was already one of the takeaways. I've got them over here in my article as well, if anyone wants to read them. And also your HTML size does matter, because the browser has to do a lot of work to render all those elements which are in your main document. And it won't impact, it isn't likely to impact, for example, your first control paint, because a browser will render elements as HTML is being streamed into the browser. However, if you've got a very large HTML page, then the browser has to do a lot of painting work, for example. And that can actually impact the overall performance and might even block the main thread of a browser. And yeah, browsers are single-threaded. There is some nuance to it, but browsers are single-threaded, meaning if you are doing a certain task, or if the browser is doing a certain task, no other tasks can be done on the same moment. And I've got an example of such situation, which might be a bit more illustrating. And it should be over here. So I've got two squares over here. And when a chat widget, like Thomas was talking about as well, or your very own first-party JavaScript, for example, if it's doing a lot of work on the main thread and blocking the main thread for a certain amount of time, no other tasks can be done. And that's what I'll be demonstrating here. So I'm going to deliberately block the main thread for 2 seconds, and I can still click the checkbox, but when I click the 2-second button, I'm not able to click the checkbox anymore. So once again, I'm not able to click the checkbox anymore. And browsers already try to do a good job themselves, because I can once again freeze my browser, but I can still do some scrolling, because browsers already thought, okay, if developers don't do their work, then we should also optimize at the same time and meet them in the middle. So any scrolling behavior is being offloaded to another thread within the browser. So that, well, once again, when there are some heavy JavaScript tasks going on in the browser, a user can still scroll, or a user can still zoom, for example. It's a little bit of a different topic, but the reason why the green square is still moving is because I am using hardware acceleration. It might sound like rocket science, but it's just run one line of CSS. Which I might show later on, or, well, let's do it directly. So I'm using GPU, the graphical card. I'm using, well, I'm basically offloading the animation of the green square to the graphical card, and you can clearly see the difference. The whole element is moving along with the selection. And I'm using transform, and I'm then using transform translate to move the green square from left to right, while for the red square, I'm using margin to animate the element. And when you use margin, or maybe top, height, or bottom or left as a, or even padding, if you animate such CSS properties, it will also block the main thread. So if you do, if you've got some JavaScript going on, you might get a laggy behavior. You might get laggy animations. So using one line of CSS being transformed, we can offload such animation to another thread, to the graphical card. And as a result, it will keep moving. The animation will keep happening while the main thread was blocked, for example. All right. What I see happening in most shops is a lot of images loading at the same time. And what I saw over here within the Quick Parts web shop, which I audited, is the first image is the main image, which was on the top of a product listing page. And in this case, a main image on the homepage itself was downloaded quite soon. However, at the same time, it is competing with other images as well. So this is why lazy loading, and we can already do lazy loading natively, meaning we don't need any additional JavaScript anymore for most browsers, by the way. It's kind of progressive enhancement, you could say. So for example, Firefox, but also Chromium-based browsers like Opera, Edge, and Google Chrome itself is already supporting native lazy loading. And it shouldn't take a lot of time to implement it. And it does come with a win in such a way that resources won't compete with each other anymore. So it's already quite a good performance win out of the box. Well, a topic we already know, like cookie notices, but also third parties, will be impacting your overall experience, or could be impacting overall experience. Third parties aren't really likely to impact your core web vitals, because a chat widget, for example, A chat widget is just sitting still in the left bottom or right bottom of the window, and it isn't pushing any contents down. It also isn't the largest element on the page, so it isn't likely to impact your core web vitals. However, obviously, there is always it depends. It also depends on how it is implemented. And that was also something I saw over here, for example, a chat widget or a site search. Those were both loaded directly into within the initial HTML payload. And as a result, they will compete with other resources, for example. They could push back maybe even your product image, which is responsible for your LCP. So as a result, those third parties which are loaded with a too high of a priority could impact your core web vitals. A better strategy is to, especially for your crisp chat, for example, to load it using Google Tag Manager. Don't use the page view trigger, but use the window loaded trigger in Google Tag Manager for third parties, which aren't important at all for user experience or for tracking purposes, for example. And yeah, basically what Thomas was explaining as well, and not all users will interact with a chat widget, and not all users will start searching the site search right away from the first second when entering a page. So that's another reason to give such resources a lower priority. You might even wonder if a chat widget should be behind a cookie notice, which is something I could demonstrate when throwing away all my cookies. All right, should be good to go by now. And on mobile devices, so let's refresh the page. And then I should be able to tell what the largest element on the page is. Luckily, it's not the cookie notice, but on some pages, if you've got a page without any images or other large elements above the fold, and I think they already used less text in the cookie notice. I think when auditing, the cookie notice was a bit bigger, but we could try and search for another page. So I'm currently opening up another screen to go to a page with less text. Well, this might be a bit too big. Maybe a listing page. Yeah, this could work, not sure. So in this case, yeah, the cookie notice is still a bottleneck on certain pages, which is also proving Core Web Vitals really is template based. You could say it might be different per template, per page type. So if you've got a product page, it's quite likely that your product image will be the biggest element because, well, it's an element above the fold, which is covering most pixels in your screen. So in this case, the cookie notice is shown later on. It's shown later than the heading, for example. And it's basically now impacting your LCP metric because first-time visitors aren't likely to, I guess, didn't accept cookies yet. So they will first see the cookie notice, but maybe only after a certain amount of seconds. It loaded within 600 milliseconds over here, but I'm obviously testing on a desktop instead of a mobile device. Although I did set this to a mobile device, I am not really simulating a real mobile device. So your page type, your type of visitors are all circumstances you have to be aware of when addressing Core Web Vitals. I think this is also a good end of my talk.